Hello everyone, I am Shivshankar. I am currently pursuing my final year BTech in Electrical and Electronics Engineering in Indian Institute of Information Technology. I am here to explain about my final year project, which is Smart Forest Fire System, leveraging IoT and Thingspeak. Basically, we are a group of 5 students research about the smart forest fire problems in nowadays. Nowadays, we have seen major problems in forest fire detecting system. So here we developed a prototype which mainly focused on giving any detects upon the temperature rise, humidity and moisture levels drop. Here we predefinedly set a threshold values of moisture, temperature and humidity levels. My project will detect these threshold values. If there is any drop in these threshold values, it will give any buzzer sound like a buzzer sound. And in cloud platform, which is Thingspeak, it continuously monitors the real-time data of the temperature and humidity and regulates the like in a graph way. So here we have seen in nowadays, like in all over the world, in Los Angeles and very different countries, early days forest fire is major issue. In early days, there is only manual observation and satellite imaging and thermal cameras are used to detect the fire.
My name is Venkat. I am explaining providing the system overview. The system architecture diagram in the information components of the various hardware components. In the basic IoT. This design to detect monitoring only things. This is using things that forest fire detecting system. So ESP32 is the control processing unit to control the data to forest fire detecting systems. Thingspeak with using DHT sensors. Soil moisture data program. The soil moisture sensor detecting the diagram of the soil with the accidental fire risk. Flame sensor is including the system for the audit risk process of the identifier. MQ2 is used to identify smoke and hazardous gases. But in process of including avoid gas sensors when the fire conductance are created on necessary process. All sensors are recording all processing units analyzed on the Thingspeak cloud platform. If threshold values across the cycle response to platform for forest line, Thingspeak seconds on the almost 5 positive sensors.
Start. Hello everyone, my name is Kalipati. Today I will explain my project working process. This is the device. It will control everything. It will be ESP32 microcontroller. ESP32 is a low power Wi-Fi enabled with brain of the system. It gathers data from the sensors and transmit it to the cloud or Thingspeak. It will process dual core. It will contains dual core extensile X6 250 Hz. It will be having Wi-Fi and Bluetooth. Wi-Fi with 802 BGM and Bluetooth with 4.2 BLE. It contains 34 GPIO pins and 520 KB SRM, and it will be extended up to 16 MB. It will operates in 3.3 volts. It used to industrial purposes, automation and agriculture and robotics. And it will be the DH22 temperature sensor. It will contains. This is DHD22 sensor. It contains. It operates at 40 degrees to 80 degrees. It sense the temperature up to 40 greater than 40 degrees, and it operates 33 volts to 5 volts 5 volts or 10 watts power. It contains used to greenhouse gases and HVAC system. Next, this is the soil moisture sensor. Soil moisture sensor. It measures water content in the soil, helping in applications like agriculture, irrigation systems. And soil moisture sensor will sense when resistance is high, soil is moist, and resistance is low. It determines the water content. It is flame sensor. The flame sensor is an essential component of the fire and flame in various purposes. The module typically consists of photodiode and transistor, operational amplifier, and the comparator circuit. It can detect 100 centimeters range. It can detect angle of about 60 degrees, means sense the flames within the range. The next is gas sensor. This is the gas sensor. It contains MQ22 and MQ135 model. It contains 4 pins: digital output pin, analog output pin, and ground, and VCC. VCC useful to give the input about 5 watts. It detects harmful gases, smokes, air pollutants. MQ22 detects LPG gases and CH4, CO2, and H2 gases. MQ135 detects CO2 and NH3 gases. This is the buzzer. It will give the sound when the smoke or any sensor will detect their detect with a high range or abnormal range. It gives the buzzer sound, and uh, the connections of the project will be this is the VCC input pin 5 volt pin, and this is this black wire will be this will be connect to one it will connect. Each pin consists of every sensor each pin consists of 3 pins. One is input 5 volt pin, and other is neutral, and one is data pin. The data pin will be connected to the microcontroller, ESP32 microcontroller. It will gives the data to the cloud platform with the help of Wi-Fi and Bluetooth.
Start. Before my friend doing, please start. Hello everyone, I am Giri. I am the one of the person in the group team. I am explaining about the software components like Thingspeak. My friend previously explained to the hardware components. First, explain about the Thingspeak. Thingspeak allows users collect and store, analyze and visualize the sensor data in real time. It is widely used to remote and monitoring applications. First of all, we create MathWorks account in Thingspeak. Another, I create a new channel with fields name or temperature and humidity and smoke levels. Once we can write and read in the Arduino IDE code to obtain the API keys to give the temperature and humidity and the smoke and soil monster values, and fire is detected and activated the alarm and water pumps. The Thingspeak is hello. The graphs are first of all we looking for the public view and private view. This is used to security access of the project. We look the graphs, temperature graphs and humidity graph and soil and moisture and flame graphs. We are real time monitoring of the data of the visualization, and the every 15 seconds data is collecting my project. Every second data is collecting the values like. Thank you for.
Understand Thingspeak graphs. These are the output graphs of our project Smart Forest Fire Alert System leveraging IoT and Thingspeak platform. These have 4 data sets. Here the first graph is of a temperature graph. Here we use DHT22 sensor, where according to the graph the temperature is slightly dropped from 29.8 degrees Celsius to 29.7 degrees Celsius. This is a minor fluctuations only, no fire risk based on temperature. If the temperature rises drastically beyond the threshold, example greater than 45 degrees, it could indicate a fire risk. And the second graph is a humidity graph. Here also we use DHT22 sensor. Humidity decreased from 65.4% to around 64.9%. The humidity is slightly dropped. Low humidity levels can indicate dry condition favorable for fire spread. And the third graph is of the gas concentration graph. Here we use MQ2 gas sensor, fluctuating values between 2.54 K to 2.58 K. The MQ2 sensor detects smoke gas. As spike here could indicate smoke presence. Again, the fourth graph is about the soil moisture. Here, the soil moisture sensor is used and it is constant at 4.10 K according to this graph. Soil is constantly dry at this reading. If this threshold matches your dry condition, it could be a fire risk factor if paired with a high temperature and low humidity. And going to the next graph, this is how the readings are sent to the Thingspeak platform. This is the second output graph. Here there is a window. This is the serial monitor window, COM3 window. Here we can see the noting of the readings and all displayed according to the graphs. These are transferred from the microcontroller to Thingspeak platform. Here these values says that the first one is the flame sensor value is detected and a smoke level is detected and alarm is triggered and water pump is activated. Data is successfully sent to the Thingspeak platform. And here the Thingspeak graph analysis shows that the MQ2 sensor also detects the smoke ranges gradually increased by the drop, and the soil moisture sensor detects and shows that a rapid drying of the soil. And the third one, and temperature and humidity graphs also shows at constant values. Fire was not triggered due to heat or dryness but due to flame or smoke levels. This is how the values are recorded in the Thingspeak platform. This shows that the data is transferred to the Thingspeak platform and processing of the data and showing the visualization of the graphs. The conclusion of the project is the smart forest fire alert system leveraging IoT and Thingspeak is designed successfully and implemented to provide real-time monitoring of environmental parameters such as temperature, humidity, soil moisture, gas levels and flame detection. By utilizing sensors integrated with an ESP32 microcontroller and the Thingspeak cloud platform, the system accurately detects early signs of the fire hazards based on threshold values. Upon detecting dangerous conditions such as high temperature, low humidity, dry soil, or the presence of smoke, the system automatically activates preventive measures like water sprinklers and buzzers while updating live data to the cloud. The observed graphs from Thingspeak confirms that the system responsiveness and accuracy is triggered alerts and countermeasures, showcasing its effectiveness as a proactive early warnings and mitigation tool. This project demonstrates a cost-effective, scalable, and effective solutions for reducing the risk of forest fires and ensure timely interventions, making it a valuable contribution to environmental safety and smart monitoring systems.